Okay, so here we are on the second part of the module for this week, dealing with Charles' law, named after a French scientist, Jacques Charles. And Charles basically, he dealt with temperature and volume. And so what do you think is going to be the relationship there? Well, when you increase the temperature, so it's a direct proportion, when you increase the temperature, you're going to increase the volume because you get the particles bopping around faster and they want to move apart, all those gas particles. So if one goes up, the other one does too. So that's Charles' law. It's a direct proportion. If the temperature is raised, the volume will go up. If the temperature decreases, the volume will go down. And again, it's a proportion. So if I double the temperature, I double the volume. If I cut the temperature in half, I cut the volume in half. Here's the equation for this one. Now it looks like a division problem. Don't let it freak you out. There it is right there. So the first volume divided by the first temperature, whatever that is, has to be the same number as the second volume divided by the second temperature. Okay, so in this case, no conversions on the volume. We're going to keep it at liters. But we have another rule here, and that is this, that whenever you do any gas problems, your temperature has to be in Kelvin. And actually it's Kelvin, not degrees Kelvin, though people say that it has to be in kelvins. And you probably learned about that at one time in middle school or something, that the Kelvin scale takes into consideration molecular or atomic movement. So it's known as absolute zero, where there is no detectable molecular vibration. It's not that confusing because every other problem you do, the temperature will be given to you in Celsius, no Fahrenheit. So the conversion is pretty simple. To convert Celsius to Kelvin, we want it in Kelvin before we do the calculations. These both have to be in Kelvin. All you do is take the temperature you're given in Celsius and add 273 to it. So for example, if a problem tells me that I have a temperature of 25 degrees Celsius, I would add 273 to it and get a total of 298 K. So there's that. This is going to go much faster than Boyle's because I've explained a lot of this stuff already. So I'm just going to kind of try to go through them. And hopefully you'll practice these and do well on the quiz with them. So again, in this first example, the information is given to us, and I always write down on the left side what I know and what I don't know. Helps me stay organized. And so here's the equation: V1 over T1 equals V2 over T2. So we're going to substitute for that, and we're going to go 3.45 liters divided by, so here's my temperature, and it's in Kelvin, so I'm good, 283 K is equal to, we don't know what this volume is. Again, I use V, you can use X, V2 divided by 91 degrees Celsius. I'm going to add 273 to it, and that's going to give me 364 K. So I'm just going to put that right up in here, 364 K. Now, the way we do this, and when you have division problems and you're solving for this, students get real confused on how to do the algebra. So here's a pretty simple way to set it up. Wherever, it doesn't matter where, it's V2 or T2 or V1, cross multiply those and put those equal to these, okay? So set those two up. So I'm going to do that, and I'm going to write out the units just at one time again so that you know what I'm doing here. So what am I going to get? I'm going to have 364 K, K times 3.45 liters is equal to 283 K times V2. So I'm just going to do this one more time to remind you that in science, and so you want to get V2 by itself. So in science, what we do is we are going to divide and make the units cancel. So I'm going to have 364K, 3.45 liters, divided by 283K is equal to V2. The K's cancel, reminding me that I have to put liters in here. Actually, mathematically, it would work out to be that I put liters in there. So again, this is all you really have to write. 364 times 3.45 divided by 283 equals V2. And if you do this in all the steps, which is how I'm showing it, now I would have 1255.8 divided by 283 is equal to V2. And we're going to get 4.44 liters is V2. Does the answer make sense? Let me see. I increased my temperature by about 80 degrees, right? 80K right there, and my volume went up. Increased temp, increased volume, looks good. Okay, we can do example number 2 now. And in example number 2, we have a written problem right here. So a gas has a volume of 6.66 liters with an unknown temp. So the first thing I see is that I have a V1 here. I don't know what T1 is. So T1 I gotta wait on, okay? If the gas is heated too, so this has gotta be my T2, and my volume is right here, and it's V2. And so notice that V2 is bigger than V1, so we should see that the temperature of the gas was lower when we started right there, because we're looking for T1. So let's write down what we know. V1 equals 6.66 liters. T1, we're trying to find. It's heated to, so that is my, it's heated to 323. So notice it's asking me about the first one at the end, but that's okay. So this is heated. I'm just going to write these out the way I always do first. T2, and now when I read it, I see heated to 323K. Hey, we don't have to convert because that's already in K, and the volume is in liters, 23.4 liters right there. So what do we have? We're going to go V1 over T1. So 6.66 over T1 is equal to 23.4 over 323. And really in the first setup, you should put your units on there. Okay, so 23.4 liters, and then 323K. So just like in Boyle's law, that first part is your setup right there. So put your units on there. Now you can get rid of them. So now go 323 times 6.66 is equal to 234 times T1. Remember to cross multiply like that and make those equal to each other and then divide it. So I typically just say cross multiply and divide is what you want to do right here. So if I multiply these numbers out first on the left side, I'm going to get 2151.2 is equal to T1. And we're going to divide that by 23.4, and this was 23.4. And so when I divide that out, I'm going to get 92.0 Remember what we're looking for here. Temperature K is equal to T1. And the last problem, another one, we're going to read it right here. See what we have. We're going to look and we see that a gas at 175 degrees Celsius, so that's my T1, has a volume of 56.7 liters. That's my V1. If the gas is heated, ooh, the volume's going to get bigger, isn't it? Okay. If the gas is heated to 550 K, and that would be my T2, what is the new volume? So my V2, I don't know. All right, let's write down what we know. V1 is equal to 56.7 liters. T1 is equal to 175 degrees Celsius plus 273 is equal to 448 K. V2 is equal to question mark, and T2 is equal to 550 K. So the setup would be 56.7 liters, okay, divided by 448 K is equal to V2 over 550 K. Remember, when I bring that over there, the K's cancel. So what I really have here is, I'm just going to write 550 times 56.7 is equal to 448 times V2. All right, so when I get those two numbers, I multiply 56.7 and 550 together. I'm going to get 3118.5 is equal to 448 V2. I'm going to bring the 448 over there. So doing all the steps right here. And so now I'm going to just divide this to equal my V2. And when I do that, I see that I have 69.6 liters is equal to V2. By the way, you don't have to show all these steps. Do what's comfortable for you. You just have to really show your setup up here. Okay, does this answer make sense? Let's see. It was heated. It went from 56 to 69. And so as the temperature increased, the volume also increased. Okay, so there's the example problems for the modules for the week. Please look over those, try those practice problems, and then try the quiz. You get 2 attempts at it, and you should get over 50% on that, I believe.